What happens when you stop using AI to help students avoid thinking and start using AI to help teachers design assignments that make thinking visible? That became the center of my classroom study this year. Students in my classes were not allowed to use AI on their own devices for these assignments. So, this was not a study about students using AI to write better answers. This was a study about whether AI could help me, as the teacher, design better science learning experiences. The question was simple. Could better assignment design move students from procedural completion toward deeper science literacy? But the deeper question is, do they understand what the science means? Can they explain the mechanism? Can they connect the concept to a real decision? Can they see the human consequences of scientific knowledge? That is the heart of soul wave science learning. Science should not only train students to get answers, science should help students make sense, take ownership, build understanding, and practice leadership. So across the year, I used a custom chatbot built around my own instructional frameworks, my teaching philosophy, and established WIDA language development principles to redesign antiquated chemistry assignments. They weren't just for decoration, they were redesigns meant to make student thinking more visible. Then I analyzed several types of chemistry assignments to see whether different assignment designs produce different patterns of student response. First, I looked at contextual baseline assignments. These tasks gave students meaningful science context. They connected chemistry to X-rays, atomic structure, periodic trends, supplements, and consumer decision making. And the data showed that students were willing to engage, but many responses stayed partial. Students could identify the right idea, but often struggled to explain the full mechanism. Then I looked at a second category, CER-based assignments. Then came the fully upgraded assignments. These assignments were designed through Soul Wave, Clear, and WIDA-informed thinking. They did more than just ask for the answer. They gave students a role. They gave students a problem. They gave students a scientific responsibility. That final assignment became the strongest endpoint in the study. The pattern was clear. Baseline assignments help students enter real-world science. CER assignments help students structure their arguments. But the fully upgraded Soul Wave, Clear, and WIDA-informed assignments created the strongest pathway into visible reasoning, ownership, and stewardship. And statistically, the Progress Monitor report found meaningful differences across assignment categories in response quality, word count, blank response rate, productive reasoning, and strong reasoning. But I want to be careful. This was not a perfect controlled experiment. I did not match every individual student across every assignment, and some handwritten assignments were not included in the study. So I can't claim that every student improved in a perfectly measured longitudinal way, but I can say this. Across the cohort, assignment type was associated with different patterns of student response, and the fully upgraded assignments pulled out richer thinking. So here's the biggest takeaway from the study. Context creates entry. CER creates argument structure, but Soul Wave, Clear, and WIDA-informed design creates a pathway toward ownership and stewardship. And that is what I believe AI helped me to do. It helped me ask better questions. It helped me build stronger scaffolds. It helped me move from, can students complete this, to, can students explain why this matters? For me, that's what it means for science to regain its soul. Science learning should not stop at naming the parts. It should help students see invisible forces, explain mechanisms, weigh risk, and take responsibility for how knowledge is used. That is soul wave science learning. When science regains its soul, learning becomes light.